You see, the Webb looks so far out that it's capturing light that's been traveling for over 13 billion years. However, the universe has been expanding, causing the light to stretch. For the most distant galaxies, we're looking back in time almost to the Big Bang. The fabric of space and time funnels you so that, in fact, you're occupying a narrower and narrower cone of space. This process extrudes you through the fabric of spacetime. Our current view of the cosmos will need to be updated in light of this. The James Webb Space Telescope has discovered something that completely contradicts the Big Bang theory, the apex of cosmic theory that explains our origins. According to Neil deGrasse Tyson, the Webb telescope detected black holes from a past universe responsible for creating our own. The James Webb Space Telescope is upsetting the apple cart. Suddenly, we realize we may have to rewrite all the textbooks about the beginning of the universe. Is it time to rewrite our cosmic understanding? If so, how significant will the revisions be? Come with us as we investigate the puzzling findings made by the JWST. Is it possible that the measurements were off or incorrect regarding the Big Bang? We will discover newly found galaxies revealed by JWST, reshaping the hot Big Bang theory. Formulating this theory was one of the greatest scientific achievements of the last 100 years. According to this idea, the current cosmos formed from a denser, hotter, and more uniform earlier state. In the 1960s, the theory was validated by the discovery of the primordial fireball, known today as the cosmic microwave background. The Big Bang has been the leading explanation for nearly 50 years on how the universe came to be. It relies on an inflationary era before the Big Bang to set the stage. However, astronomers and astrophysicists have long raised persistent objections to cosmic inflation and the Big Bang. The JWST has now discovered a new issue, adding additional complexity to the cosmic tale. The JWST may change the way we understand the cosmos if it finds early galaxies far larger than expected. The discovery of these massive galaxies in the early cosmos by the JWST suggests that our current view of the cosmos needs re-evaluation, as current astronomical models do not align with this finding. In its brief operational period, the James Webb Space Telescope has revealed previously unseen details about the cosmos in the first few hundred million years following the Big Bang. The James Webb Space Telescope has caused quite a stir. Suddenly, we might need to revise every single textbook on the origin of the cosmos. The discovery of massive, star-rich galaxies has been startling. By using the JWST's infrared sensing instruments, scientists have identified 6 massive galaxies that existed in the early cosmos. If the size of these objects is verified, they could fundamentally change our understanding of galaxy formation. These findings, based on data from the James Webb Space Telescope and published in Nature, depict the universe as it was 13.5 billion years ago, or about 3% of its current age. But what exactly are these perplexing galaxies? These mysterious galaxies, showing signs of maturity comparable to our own Milky Way, which is 13 billion years old, appeared just 500 to 700 million years after the Big Bang. The stellar masses in these astronomical bodies are several billion times greater than our Sun's, with one possible monster boasting a whopping 100 billion times the mass of our Sun. The Milky Way holds about 60 billion suns worth of stars, making these galaxies much larger. Expressing her shock, study co-author and astronomer Erica Nelson from the University of Colorado Boulder described the sudden appearance of such massive objects as perplexing. This is a huge discovery, we think it's an enormous revelation. The most exciting aspect of this remarkable instrument, the telescope we've put in space, is finding things we didn't expect and can't explain, prompting us to revise our understanding of the universe. In the early cosmos, galaxies with stellar masses comparable to the Milky Way formed rapidly, which defies conventional wisdom. This surprising discovery contradicts the long-held belief that galaxy formation is a gradual process beginning with tiny star and dust groups. Conventional thinking held that structures in the early cosmos formed slowly. Yet, the newly discovered gigantic beings challenge this story. The lead researcher, Evo La, questions the acceleration to maturity in these monsters. Popular assumptions suggest that big galaxies in the universe didn't form overnight, and this discovery challenges that notion. Astronomers informally refer to these objects as universe breakers, and they are living up to their moniker by altering our perception of cosmic expansion. Although not directly involved in the research, English astronomer Emma Chapman from the University of Nottingham argues that if these findings hold, our understanding of the early cosmos could be fundamentally altered. The discovery of massive galaxies around the Big Bang raises questions about a dark cosmic period and suggests that star creation might have occurred earlier than previously believed. However, scientists caution against rewriting cosmology just yet. One hypothesis is that some of these objects might be obscured by supermassive black holes. What appears as stars in the images could actually be dust and gas collapsing under gravity. Black hole development and expansion in these early years remain mysterious. Another scientist who did not participate in the study adds that this new evidence does not disprove cosmology but raises questions about the formation and growth of these objects. To confirm their findings, scientists may use spectroscopy to analyze the spectra of the detected objects, which would reveal their age. The light from early cosmic galaxies has stretched significantly, indicated by their high redshift. A higher redshift suggests that the light has stretched, indicating the galaxy's greater age and distance. Spectroscopy can confirm the age of these galaxies, designated as high redshift candidates, or determine if they are truly redshifted from a more recent cosmic era. Despite the need for additional observations, astronomers speculate that the detected mass signifies a surprising discovery. Even with a 50% reduction in sample size, the known stellar mass from this cosmic age might be 100 times more than previously thought. Professor Michael Boylan-Colchin from the University of Texas at Austin sheds light on the matter in Nature Astronomy. According to the Lambda CDM model, dark matter and ordinary matter were extensively combined in the early cosmos. A portion of this ordinary matter turned into stars as dark matter halos collapsed, forming the first galaxies. Boylan-Colchin concluded that almost all matter would have been used for star formation, which he found implausible. The Lambda CDM model still stands as the best match to current evidence, and Boylan-Colchin refrains from dismissing it, suggesting that replacing it would be a last resort. MIT's Mark Vogelsberger praised the theoretical approach of the study, pointing out that the robustness of the estimate comes from minimal assumptions. While the calculations are intriguing, Boylan-Colchin stresses that for now no other theory matches Lambda CDM's explanatory power. But are there any other possible reasons at work here? Mysterious findings. A fascinating early galaxy discovered just 500 million years after the Big Bang was revealed by Haley Williams, who led a team from the University of Minnesota. The low appearance of the galaxy is also dependent on gravitational lensing amplification, which is observed with the JWST. Compared to galaxies from a little later period, its star production rate is tens of times higher. As Williams points out, although this galaxy is less in mass than the one studied by Bone-CIN, Williams makes an educated guess on whether or not this intense star formation may be applied to galaxies with larger masses that are at the same redshift. Nevertheless, Bone-Cullen continues to exercise caution. Due to the object's diminutive size, it is only 105 light-years across, much smaller than the average galaxy. He mulls over the idea that it could actually be a globular cluster. Lambda CDM changes are one possible solution to the cosmological model tension. Early dark energy (EDE) suggests changing the behavior of dark energy just after the Big Bang. This modification has the potential to bring the Hubble constant-related disagreements into harmony with other observations. According to these theories, the early cosmos had more matter than it actually has. In this case, according to Bone-Cullen's calculations, early galaxy matter densities would quadruple, meaning that hyper-efficient star formation would not be necessary to attain the same results. Nonetheless, contrary to the 13.7 billion years deduced from alternative data, EDE models maintain that the cosmos is merely 13 billion years old. A second possible explanation is that astronomers have mistakenly identified stars as the source of part of the galaxy's light. The light probably comes from accretion disks around supermassive black holes, according to Bone-Cullen, who thinks this is the most likely explanation. Having only seen a small number of these galaxies thus far, astronomers warn that the small sample size might not be indicative of the entire universe. The tension that was noticed might go away if thorough statistical surveys were conducted, according to Penn State professor Joel Leha, who had no involvement with the study. But is it true that these galaxies are very far away? Nearby, low-mass galaxies can appear like distant big ones, as pointed out by Peter Berui of the University of Arizona, who is also not involved in Bone-Cullen's study. Additional measurements are needed to reach definitive conclusions. Most importantly, spectroscopic observations of these galaxies are still missing, which would allow us to learn their actual distances and look for evidence of black holes. In light of new information, Michael Bone-Cullen predicts that the seriousness of the problem will become clear in a few years, if not sooner. We can look at the astronomer's hypothesis on this occurrence to pass the time till we get this data. An as yet unidentified process may be operating here. According to some astronomers, if we assume that enormous black holes may have existed in the early cosmos, then this riddle could be solved. As far as astronomers are concerned, if this assumption is correct, we will finally understand the presence of large galaxies in telescope surveys. The challenge, though, is to provide an explanation for the sudden proliferation of black holes in the early cosmos. This is where a highly contentious hypothesis put out by a Nobel laureate comes into play. An assault on credulity. According to the currently accepted account of creation some 14 billion years ago, all that is or ever will be existed inside a tiny, endlessly dense point. Everything in our visible cosmos originated from this singularity, which erupted in the Big Bang. The Big Bang can be simplified to this level of simplicity. Still, a lot of physicists think that 13.7 billion years isn't long enough for complex structures like superclusters to evolve. The standard Big Bang theory is being challenged by an Oxford University scientist, who hopes to prove his points by using remnants of the cosmic microwave background radiation, which was created when the universe was only 300,000 years old. According to this scientist, the Big Bang was just one event in a long series of similar explosions called eons rather than the beginning of time. A new epoch in cosmic history was marked by each of these occurrences. Sir Roger Penrose, who will be awarded the Nobel Prize in Physics in 2020 for his work on black holes and mathematical approaches, has put up the theory that our universe has seen many Big Bangs and that there will be another one in the future. The development of mathematical methods that Penrose helped progress led to the Nobel Peace Prize. These methods validated and expanded upon Albert Einstein's general theory of relativity. On the topic of black holes, he explored their complexities and showed how dense objects collapse under gravity to form singularities, or places of infinite mass. Penrose repeated his unconventional idea, calling it crazy when accepting the medal. As the cosmos continues to expand, eventually all matter will disintegrate, triggering a new Big Bang and the beginning of an entirely new universe. In an interview, Penrose shared his firm belief that the Big Bang was not the beginning, but rather that something existed before it and that something else is on the horizon for humanity. Accordingly, how does the scientist back up his hypothesis, which he calls conformal cyclic cosmology? 6 hot spots in the sky called Hawking points, each around 8 times bigger than the diameter of the Moon, have been found, according to Sir Roger Penrose, who is challenging the current Big Bang theory. These points, which are named after the late Professor Stephen Hawking, who postulated that black holes evaporate after emitting radiation, indicate the possibility of their existence. However, it is highly unlikely to be observed within the present age of the universe, which is 13.77 billion years. Penrose states simply that our universe is not the first nor the last, but rather that it evolved from a densely packed, highly structured mass into the complex reality that we see. Unless something happened long before the Big Bang, the current inflation-based Big Bang model cannot account for the presence of a low-entropy, highly ordered state during the birth of the universe. Our cosmos has and will again revert to a low-entropy state as it approaches its final expansion into nothingness, leaving behind a cold, black, featureless void. According to Penrose's theory, dead black holes can be seen. They are the leftovers of universes or eons that have passed. A confirmation of this could also lend credence to Hawking's theory. Monthly notices of the Royal Astronomical Society covered Penrose's 2020 paper in which he found evidence of hot, spherical anomalies in the microwave background. The data on these sites were validated by around 10,000 simulations and came from the Planck 70 GHz satellite. Henner suggested in 2018 that radiation hotspots in the cosmic microwave background could be the result of black holes vaporizing. According to a cyclic cosmology paper by Penrose and Veed Gordon in 2010, the uniform temperature rings in the cosmic microwave background, CMB, are the result of gravitational wave signatures from black hole collisions in an earlier universe. Entropy is reduced because black holes emit radiation and destroy matter. The last black holes will either vanish or combine as the universe nears the end of its expansion, bringing back some semblance of order. This smooths out the spacetime geometry from its present ragged shape and brings about a state similar to the Big Bang after the cosmos stops expanding. Penrose's model predicts that it will collapse into a highly organized system, marking the beginning of a new eon that will culminate in the next Big Bang. Contrary to popular belief, Penrose contends that variations in CMB temperature should not be random. Evidence of gravitational waves from eons ago was suggested by more than 12 concentric rings that he and Gordon discovered in NASA's WMAP satellite data. If confirmed, Penrose's conformal cyclic cosmology would mean that our universe is just one among many potentially endless eons old, ruling out the necessity of a Big Bang forerunner. Though debated, the idea poses serious challenges to long-held beliefs in the cosmology community, and if proven correct, would have far-reaching consequences. Some people think it's hard to believe that the universe can go from being infinitely big one instant to being incredibly tiny the next, meaning that particles must lose mass as the cosmos becomes older. Share your thoughts on whether Penrose's theory holds water or if it's another Big Bang notion that will fade into oblivion. For more, subscribe and leave a like.